Hello everyone, and welcome back to another troubleshooting video. So, right here we have a GTX 570 DirectCUII from ASUS. And this is the first time we bought a dead card. That's not actually for me. This one's also going to FCR.IX, who also got the 460 WHDI. And basically why we picked up this card is because he's already gonna pay for I think it's usually 35 euros or something to send the 460 to the US. And we both thought if we're gonna pay that much for the package, we might as well fill the package up to the weight limit and just look for some other nice things that could maybe be of use. And then we found this 570 for 10 euros, described as broken. Nothing described what's wrong with the card. I have a pretty good idea what's wrong with it because it's a Fermi. But still we're gonna go through the entire troubleshooting procedure. Anyway, we saw the listing and we're like, it's a DirectCUII, those have a pretty good VRMs, it's 10 euros, so that's a very cheap 10 euro e-power, because, I'm not expecting the VRM on this to be dead. What I'm expecting to be dead is either memory module or the core, basically substrate to die connection issues, or maybe if the card it's a little bit bent, but I've seen worse. Sometimes you have your BGA break under the memory chips when the card bends too much. So basically what I'm expecting is that the card works, but artifacts and doesn't install drivers or something. So by the end of this video, we're probably gonna have a MATS report. It's probably gonna show one memory module that's dead, that's what I'm expecting. I don't think the card will ever be fixed because it's a 570. It is very much a 10 euro e-power. But hey, might as well go through the troubleshooting procedure to just get out another video on it's not the first okay, I don't know if this one is an artifacting card, but I'm 99% sure it's an artifacting card. Not the first time I've had this on the channel, but still, it's always nice to see the procedure to go through when you have a dead card. So anyway, card's still assembled. That's how I got it. It's mostly dusty, but seems to be in a okay physical condition. So the first thing we're gonna do is just remove the cooler. Just remove everything cooler, VRM, heatsink, backplate. Just take a good look at the PCB. See if anything obvious is wrong with it. If we don't find anything obviously wrong with it, then we can make some measurements. And this fan connector isn't coming off. I'm gonna rip the cable on this one. Not that it matters much. I don't even know if he wants the heatsink. Could just... Honestly, this is one of the worst heatsinks ever made. No one's gonna want to buy this. Okay, yeah. So we still have a VRM heatsink and a backplate. You can already see it's pretty similar to the GTX 580 DirectCUII. It's, well, basically the same PCB, just with a 6-phase instead of an 8-phase for V-Core, and it has only one high-side MOSFET instead of 2. Still a very decent VRM though, because if you want to have some specific information about it, Buildzoid did make a PCB breakdown on this card. He's gonna have some more info on the MOSFETs and the efficiency and current ratings and everything, so if you want to have some more info on the card, go look up his video on it. But yeah, basically the point is that the VRM is good enough to be an e-power for, say, a GTX 260 or a 680, some older cards or some medium to low power 28 nanometer cards. Could also pop this onto a 1060, but 1060 is not really cheap enough right now. So last screw. That's interesting. I see some silicone oil residue here from what probably was a thermal pad, but we don't actually have a thermal pad. So this card was probably disassembled before. All this discoloration is coming from something else, but I think that looks very much like the stains that you get from leaking thermal pads. Alright, so here we have the PCB. First thing I always check is the PCIe decoupling capacitors. I once had a card where this very first one was missing, and the card was not detected because, well, if the first PCI Express lane doesn't work, none of them do. So the card was not detected. I put that capacitor back on, and that was the entire fix. But it looks like all of them are present. So nothing super obvious here. Then looking around the core and memory section, there's not really any physical damage that we can see. No burn damage at the VRM. So it looks mostly good. Front side, kind of same thing, with no really burn damage anywhere. So the card looks mostly good. Alright. So then let's do some measurements. So first measurement always is testing the power inputs. That's our 3 12-volt inputs and our one 3.3-volt input. So I'm just gonna put my ground probe to the I/O shield because that's always ground. And we're gonna test the, if my memory is correct, I haven't done this in a while. It should be the first 3 pins on the left. That's 12 volts from PCIe, and we have no beep, everything's good. We can also check the fuse. Both sides are okay, so the fuse is not blown, and we don't have a short on this 12 volt power plane. Then the 3.3 volt pin is, you go here and then go 4 pins left, 1, 2, 3, 4. That one's good. I have to say on the GTX 480 reference PCB, the 3.3 volt pin does beep in continuity mode because that card on this pin just has a naturally very low resistance. So that card will always show a short, and since this is a 570, it's kind of similar. Maybe some designs do that too. Then we have our connector notch right over here. That means the exposed pins are ground. I'm just gonna go off the fuses. Both sides are good for the 6 pin. And also good for the 8 pin. These fuses are both in parallel, so you only really need to test one of them. So our power inputs are all good. So now we go into resistance mode, and now we will measure our outputs. So let's get on the back, and we are going to check our V-core resistance, 0.9 ohms, a bit floating around, but that's okay. Memory resistance, 60 ohms, that's okay. Then that's a bit different from the 580. Usually on the 580 the PEX rail is over here. It's probably the BIOS chip, and then this is probably the PEX rail. I don't really know where to... Yeah, I don't recognize that IC, and I don't really see... Well, maybe that is an output capacitor, but it could very well be something else. Okay, I'm not really sure where to measure PEX, so... Yeah. So I just not gonna measure PEX. Then, one thing we can also do is check some more pins. 3 express slot. I don't quite remember what the pins are, so I can't really... Yeah, so there's a reference clock plus minus pin, there's a PEX reset pin. I haven't done this in a while, so I kind of forgot where they are. You can measure those too. If any of them show short, then you probably have a dead core. what we can do is go back into continuity mode, and we're going to check some of the PCI Express data lines. So you can kind of see how how you have 2 pin pairs for each PCI Express lane going to the core. You can kind of see the traces. And we're gonna measure the first pair and then a random pair and compare the voltage drop that we get. So we get 650 millivolts here, 650 millivolts here, and then just take a random pair. 700 millivolts and 650, okay. So that one's reading a bit high. No, actually now it's also reading 650, so it was just bad contact. So all of those are fine. If you can see some very huge differences in the voltage drop or just also a short pin, also indicates dead core. So yeah, but so far all the resistances check out, which is what I expected. And I'm gonna clean the core a bit. So that I can touch it to check if it gets warm. Don't really want thermal paste on my hands, so I can de-dust the PCB a bit. Okay, so now we can turn the card on, check our voltages. I'm probably expecting to see an image. And like I'm expecting to just see an image that, so either a clear image and then the driver doesn't install, or just artifacts and well, the driver also doesn't install in that case. So we're just gonna do that. Gonna set the card up and then see if I'm probably expecting it to boot up and just artifact. But if it doesn't, we can go measure some voltages. I think I should just measure voltages anyway. Just to check if everything's alright. So I'll be doing that then. See you soon. Right, card's on that bench, turning it on, and let's measure some voltages. We have memory, and I already see an image. Let's go get a core. We have core voltage. Let's see if we have 5 volts. And then, well, we see an image and it's artifacting. Yeah. Don't really have a point in measuring packs. It's gonna be around 1 volt. So, yeah. We have a card that's artifacting. Doesn't install the driver. And basically that's it. So, I'm gonna turn it off now, because probably overheated. Didn't even get that hot. Anyway, yeah, it happened what the expected did happen. Card is artifacting, so there's one of those memory chips is dead, or maybe just an issue with the core itself. I'm gonna do a run of maths on this card, and it's probably gonna tell us which chip is the problem, or if it's showing all chips, it's probably the core, or just one bank group, then it might also be the memory controller. So I'm gonna do that now. So the card's now running maths, and maybe we'll even see some artifacting in the test already, though it doesn't look like it. Still expecting it to fail though. Yep, we failed. Okay, let's reboot and read the report in Windows. Okay, I had some difficulties finding out which one is the correct report, because I have 2 USB sticks with mats on them. But this is the correct one. And yeah, we have a dead memory module. So I should have a explanation chart in this one. Yes. So, we have problems in bank E, and we have the 31.0 module is the problem. So, well, in this image it doesn't have a bank E, but yeah, so you start like this: A, B, C, D, and then there would have been an E on our card. There is an E. And you can see the 31.0 module is always the second one. So it's not the very last one. There is a bank F. There's no bank A because it's a 570. It doesn't have the, like it only has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 modules and not 12 like the 580. So bank A is not populated on this one and therefore it's not active. The memory controller for that is disabled. But we have our problem here. It's it's E0 because so there's two ways of how to handle these. So the 6332 is 1 and the 31.0 is 0. So A1, A0, B1, B0, C1, C0, D1, D0, and then we have E1, E0, and then F1, F0, and so on. So it's the second one in bank E, even though it shows up as the first one here. So you have to be careful that these are flipped. So anyway, yeah, that's the problem we have with the card. I guess I could show the module to you. So here we have the card, and you can see I've already marked the dead memory module. So to reiterate, our dead memory module is E0. And the way you identify the memory modules is basically you look for the upper left corner of the GPU, which you can see there's like a little dot here, and then on the PCB there's also a little arrow right there. So that's the edge that's marked. Then you go to the opposite edge, which is this one, and that's where you start counting. So A1, A0, B1, B0, C1, C0, D1, D0, E1, E0, which is dead, and then F1, F0. So you can see on the 570 bank A doesn't exist, that's why it didn't show up in the report. But bank B, C, D, E, and F do exist. And that's F0, that's E0, that's all that module. So theoretically, to fix the card, we need to replace the module, and then the card should be fixed. There is a slight chance that the problem is actually within the maybe the BGA of the core or the memory controller in the core, in which case replacing the module is not going to fix the card, but most of the time it's the memory module itself. It can happen that the core has problems because, like, especially on these big cores that run really, really hot, if they run through enough thermal cycles, it can sometimes crack the BGA or also the die to substrate connections in the core. And those are pretty hard to fix and not at all worth fixing on a card like this. Even swapping the memory module on a card like this is not really worth it. I mean, the reason we picked up the card is to turn it into an E-power, and that's probably what's going to happen. But hey, we still went through the diagnosis phase. Like, you can adapt to every other card. Like, this applies to every NVIDIA card. Of course, the PCB is going to be different, but the principles of what we're doing do not change. So, yeah. There we go, card's diagnosed. I'm not expecting this one to be fixed. This one's just gonna get like cut around here, and it's gonna actually can show that. The card is gonna become something like this. So this used to be a GTX 580 DirectCUII, so you can see it's very similar. It's got two more phases for vCore, and basically what's gonna happen to the card, it's gonna get cut like this, and then become an E-power module like this one that I made. So that's what's probably going to happen to the card, but theoretically, if this was like a modern, more desirable card, swapping out that memory module would probably fix the card. So yeah, with that we are at the end of this troubleshooting diagnosis video. yeah, if you haven't seen an artifacting card before, now you know how to diagnose it. If you're looking for a tutorial of the MATS software, you can go look up the YouTube channel from Tech Cemetery. He has a tutorial for using the software. He has since transitioned to a more advanced software that I haven't used yet. So the tutorial is kind of outdated, but it works for what I did here. Sometimes MATS doesn't detect errors on faulty memory modules. Here it did detect them, but sometimes you can have cards that show up as a pass and still have dead memory modules. In that case, you want to use that more advanced software. But I've never used that more advanced software. I might in the future, like once I get a card where I suspect the memory module is dead and MATS doesn't find the errors, that's the point where I'm absolutely gonna use that more advanced software. For now, MATS has always worked well for me. So yeah, if you want a tutorial for MATS, look up his video on it. He should be in the other channel category on my channel as well. You can find him that way or just Google. Anyway, yeah, thank you for watching. Hope you enjoyed, hope you learned something. And until next time, goodbye.